Welcome back to another exciting video on how to miscode. Today we are going to delve into the fascinating world of steganography. Have you ever wondered how secret messages can be hidden within images? Well, steganography holds the key to this intriguing technique. Steganography is the art of concealing information within other data, such as images or audio files, without arousing suspicion. It's like hiding a needle in a haystack, but in this case, the needle is a hidden message and the haystack is an image. Let's explore how it works and where it can be used in real life. Imagine you have a sensitive message that you want to send without attracting attention. Instead of encrypting it or sending it through secure channels, steganography allows you to embed that message with an innocent looking image. To do this, we'll be using the lsbsteg Python module. In front of me I have three files that we'll be working with today. The first file is lsbsteg.py, which contains the core functionality of our steganography tool. It provides functions for encoding and decoding hidden messages within images. Here you can see the structure of the module and its various functions. It uses the OpenCV library for image processing and the doctop library for command line argument handling. We have a class called lsbsteg that encapsulates the steganography operations. One of the key methods in the lsbsteg class is the encode text method. Let's take a closer look at this important piece of code. In the encoding script, we create an instance of the lsbsteg class and pass it the image we want to modify. Then we use the encode text method to embed our hidden message into the image. This method takes the input image and the message to be hidden, and it produces an output image with the hidden message. Now, let's move on to the decoding functionality provided by the lsbsteg class. This allows us to extract hidden messages from images. In the decoding script, we read the modified image that contains the hidden message. Again, we create an instance of the lsbsteg class and pass it the image. Then we use the decode text method to extract the hidden message from the image. This method retrieves the hidden message from the image, allowing us to reveal the concealed information. But how does the lsbsteg module actually embed the message into the image? Let's take a closer look. When we want to hide a message, the lsbsteg module converts each character of the message into a sequence of 8 bits, which is called binary representation. This allows us to work with individual bits of the message. In the code, we take each character of the message and convert it into binary format. For example, the letter A might be represented as this. We store these binary representations as a series of bits. Now comes the interesting part. We modify the pixels of the image by changing the least significant bits of their color values. The LSBs are like the hidden corners of each color channel: red, green, and blue. We use these corners to store our message bits without significantly affecting the image's appearance. In this code snippet, we access the pixel value of the current position in the image. Then we apply bitwise operations to manipulate the LSB of each color channel. If the message bit is 1, we set the LSB to 1 using a bitwise OR operation. If the message bit is 0, we ensure that LSB remains 0 using a bitwise AND operation. This process is reminiscent of hiding a secret message within a painting. Imagine a master artist subtly altering certain brushstrokes or adding hidden symbols within their artwork. These subtle changes go unnoticed by most observers, but to those who know where to look, a hidden message reveals itself. Similarly, in steganography, we manipulate the LSBs of pixel values, weaving our message within the digital canvas of the image. By cleverly modifying the LSBs of the pixel values throughout the image, we hide the message within the image's pixel data. This process is like blending the message into the image, making it invisible to the human eye. Now it's time for a demo. I'll guide you through the process step by step so you can see steganography in action. Let's first open the decoding file. Locate this line. Here you will need to replace mynewimage.png with the name of your modified image file. Once you have made the change, save the file. On one side of the screen we have the decoding file, and on the other side we have the modified image. Let's execute the decoding script and see what hidden message it reveals. As you can see, the hidden message is successfully extracted from the image. It's incredible how steganography can conceal information within plain sight. And there you have it, a glimpse into the fascinating world of steganography. With the lsbsteg module, you can encode and decode hidden messages within images, opening up a world of possibilities for secret communication. If you enjoyed this video and want to learn more about coding and exciting technologies, don't forget to subscribe to our channel. Like this video and share it with others. If you have any questions or suggestions, please leave them in the comments below. You can find the code and other resources on our GitHub page, which is accessible through the Artemis Coder website. The link will be provided in the description. Thank you for joining me today and happy coding.